Global supply chains are vital for transporting products and services and are crucial for the world's economy.
The global supply chains are currently under pressure, and for Indonesia's leading fertilizer producer, Pupuk Kaltim, stability means more than just a business. It is about food security for millions. But with rising natural gas costs, climate unpredictability, and reliance on imported raw materials, the stakes are really high. And that is where we come in. My name is Niklaus Setiadi, a member of EcoTechpreneurs. Our team is here to tackle these challenges head on.
Being one of the biggest fertilizers producers in Southeast Asia does not mean it's all easy for Pupuk Kaltim. The company needs to enhance their performance further in order to ensure the business stability. One of the efforts is through their supply chain management system.
Hi, my name is Anya and I'm a member of EcoTechpreneurs.
In strengthening the company's supply chain, Pupuk Kaltim aims to prioritize the domestic market to strengthen food security while fulfilling diverse markets and holding agri-solution programs for farmers. In order to increase efficiency in the midst of the modern era, Pupuk Kaltim ensures to strengthen their digitalization through the integrated system, smart production, which also aims to be further developed in the future. However, the company is facing several challenges in several aspects, such as external conditions, competitiveness, regulations, and raw material needs. Here, we have provided a thorough situation analysis using several tools, PASL and SWOT. Based on our PASL analysis, some of the external factors that may come as emerging threats for Pupuk Kaltim is on the first, political aspect includes the company dependence on government-provided natural gas to produce ammonia for fertilizers need. Second, economic aspect, the raw material prices that are imported and global competition. Third, legal aspect, which includes trade restrictions. And fourth, environmental aspects, which include the climate change impact on raw material supply and pressure for reducing carbon footprint. And based on our SWOT analysis, we've analyzed Pupuk Kaltim's weaknesses on several aspects, such as: first, the dependence on natural gas to produce ammonia. Second, high import of raw materials makes up above 60% of NPK's raw materials, and supply chain inefficiency. While the threats are the same as PASL, covering climate change uncertainty, imported fertilizer competition, and potential government regulations change regarding natural gas usage. With these analyses being conducted, we discovered that the main concern for Pupuk Kaltim is the inefficient supply chain management, which leads to cost inefficiency, which caused by four root issues, namely: A. Pupuk Kaltim's dependence on government-provided natural gas excess. B. Above 60% of NPK's raw materials are imported, leading to cost and time inefficiency. C. Inadequate supply to fulfill high demand of fertilizers, which caused high competitiveness against imported fertilizers. And D. Uncertain climate conditions affecting raw materials supply. With these challenges being identified, our business question is: how can Pupuk Kaltim increase efficiency in its supply chain management through the production process while fulfilling the high demand of fertilizers in the midst of climate uncertainty? And with that, the EcoTechpreneurs is proposing the AnvayaSutra project.
Our first solution addresses Pupuk Kaltim's heavy reliance on government supplies natural gas for ammonia productions. Hello, my name is Josephine Adeline. I'm the member of EcoTechpreneurs. This dependency introduces risks to the fluctuating availability and price. We propose an alternative approach by producing ammonia from cow manure, transforming a local resource into a critical raw material for fertilizer manufacturing. Pupuk Kaltim can cooperate with PT Berdikari Persero and PT Raja Wali Nusantara Indonesia as supplier of cow manure. This process begins with mixing cow manure and water in a 1:1 ratio and introducing Clostridium sporogens bacteria. This bacterium accelerates protein degradations, releasing ammonia gas and beneficial byproducts like nitrogen and acetic acid. Maintaining optimal conditions with temperature 37 degrees, humidity at 70%, and a natural pH maximizing bacteria efficiency. The use of Clostridium sporogens bacteria help reduce methane gas because Clostridium sporogens bacteria use hydrogen as an energy source so that methane bacteria cannot grow properly. This is very helpful in reducing greenhouse gas and preventing global warming. The ammonia gas is captured for fertilizer productions, while the leftover nitrogen-rich compost can be used as an organic fertilizers after distillations. These solutions not only decrease reliance on natural gas but also support local agriculture by sourcing manure from Indonesian farmers and promote sustainability through organic waste recycling. The use of ammonia production machines can help solve the natural gas problem by up to 40% because the ammonia produced per year is approximately 42,000 tons. To address the high cost and dependency on import material of NPK fertilizer productions, we propose a shift toward local sourcing for nitrogen, phosphorus, and potassium. This approach strengthens supply chain control, reduce costs, and align with Indonesian circular economy goal. First, nitrogen need can be met by utilizing the ammonia derived from cow manure. As outlined in Solution A, the phosphorus pupuk Kaltim can partner with local micro farmer operate by state-owned companies like PT Perusahaan Perdagangan Indonesia, producing phosphor-rich compost known as Kaskot. Additionally, working with PT Perusahaan Perdagangan Indonesia, maggot can be fed by concentrate diet to filter and change phosphorus content. And finally, potassium can be obtained by processing food waste from local restaurants. The resulting potassium-rich kaskot provide a sustainable source for NPK fertilizer productions. By sourcing this ingredient domestically, Pupuk Kaltim can reduce import dependency, support local industry, and promote sustainable waste management.
To ensure a smooth process, we recommend investing in machinery capable of processing cow manure, which will produce ammonia gas. This gas can support Solution B and be utilized alongside Solution A. We have also designed a detailed sketch to visualize how the machine would look and function, providing a clear overview of its role in the process.
Pupuk Kaltim faces a challenge in facing competition against imported fertilizers. We realize that this issue is caused by the production schedule and planning that does not align effectively with the market demand, resulting in an inadequate supply to meet high demand despite plants' capacity to produce large amounts. The unexpected fluctuating model led to pressure for the government to import fertilizers, hence increasing the competitiveness for Pupuk Kaltim against imported fertilizers. To tackle that, we're proposing optimization of smart production system for integrated information by implementing demand planning analytics. Implementing a demand planning analytics system in Pupuk Kaltim's existing demand planning and control system will optimize manufacturing and distribution process. The system integrates data from procurement to distribution, enabling real-time updates on sales, warehouse stocks, facilities capacities, throughput, and delivery lead times. By utilizing the demand planning analytics system, Pupuk Kaltim can increase its competitiveness in the midst of imported fertilizers. The system will help Pupuk Kaltim to increase supply chain resilience in fulfilling products' demand and avoid risks regarding unexpected demand.
Our final solution addresses climate risks in Pupuk Kaltim's upstream supply chain. By partnering with BMKG, we integrate real-time climate forecasting into the Juara app, enabling proactive adjustments to production and supporting Scope 1 sustainability goals. The Juara app logs responses to climate events, optimizing Pupuk Kaltim's processes for a more resilient supply chain. Guagam fertilizer enhances crop resilience, helping farmers sustain harvests and demand for Pupuk Kaltim's products. This supports the downstream supply chain and aligns with Scope 3 sustainability efforts. The solution strengthens Pupuk Kaltim's supply chain, sustaining production, supporting sustainable farming, and reducing carbon emissions for Indonesia's agriculture. Cow manure dependence can be mitigated by securing supply partnerships which automate fermentation. NPK variability can be done by quality control and diverse suppliers. Employee adaptation by providing targeted training, AI limitations by calibrating using backups and running pilot programs, Qualcomm adoption by pilot programs and incentives. Now for the expected impact. Ammonia production can cut gas reliance and boost stability. NPK production can lower imports and strengthens local supply. Smart systems can increase supply responsiveness. Climate collaboration can improve efficiency and cuts costs. Guagam can stabilize the supply and boost sustainability. Solution A will cost 501 billion, Solution B will cost 528 billion, Solution C will cost 10 billion, Solution D will cost 134 billion. Through Project AnvayaSutra, Pupuk Kaltim aims to enhance supply chain resilience, achieve cost savings, and generate 90% profit margin by leveraging sustainable solutions and climate-resilient products.